So in this video we're going to be covering Isosceles triangle theorem. Basically what that is, if a triangle is isosceles, meaning it has two equal sides, then its base angles are congruent. So these two angles would be considered our base angles. By the way, just a quick note here, each of these sides that are congruent would be referred to as legs. This is my base. These are referred to as my base angles. If you're wondering what this angle up top is referred to as, it would be the vertex angle. Now, the converse of the isosceles triangle theorem is also true. Therefore, it actually makes a good definition and a biconditional. If two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if this is basically just starting differently, where you have two congruent angles, well, the sides across from those angles would have to be congruent, and you would have an isosceles triangle. All right, moving right into our first example. And as I'm looking at that, what you're going to want to recognize is that it is isosceles, and the base angles would be the 2x minus 8 and the 64 degrees. Now, since it's isosceles, I know that these two things have to be equal. This angle does not have to be equal to those two, though. The vertex angle can be different. But these two angles are congruent. I would set this up as 2x minus 8 would equal 64. I would add the 8 to both sides. So 2x would equal 72. And I would divide by 2 on both sides. So x would equal 36. I'm going to reference the instructions really quick. Find the value of x, and that's exactly what I was supposed to get. All right, moving on to example 2. Find the value of st. So the previous one used isosceles triangle theorem. On this one, though, what you're going to have to do is use the converse of it. So since I have two angles that are congruent, the sides opposite of those angles have to be equal. So the 5x minus 6 would equal the 3x plus 4. Sometimes they would also have an expression written out on RT, maybe have something like 15x plus 7. But that would be just something that you would want to ignore, since the base doesn't have to be equal to the two legs. So these two do equal each other. So I'm going to write down really quick that 3x plus 4 does equal 5x minus 6. And now I'm going to solve this equation. I'm going to start by getting the x's together. I chose to minus 3x from both sides, so that 4 would equal 2x minus 6. Now I'll add the 6. So 10 will equal 2x, and divide by 2. And I get that x equals 5. Now, this is not completely finished here. The task at hand was to find the value of st. So I do need to use substitution property with that value of 5 to plug that back into the appropriate measure. So st will equal 5x, which I now know is 5, minus 6. You can see I substituted the value of 5 in for x, and 5 times 5 is 25. And 25 minus 6 is 19. So st equals 19. That's my true final answer on example 2. All right, moving on to example 3. What we're going to see here is yet another isosceles triangle. Now, this one is a little bit different because it's dealing with the vertex angle. This was a little tricky problem, so I wanted to show this in an example. Basically, what you'd have to consider is that these two angles are probably not equal. In fact, I know that they're not. What's going to happen here is the 52 degrees can get moved over here, though, and now we can use triangle angle sum theorem. So since this is 52 degrees by isosceles triangle theorem, I can set this up as the 5x plus 4 plus this 52 plus what I now have determined this must be 52 since the triangle is isosceles, has to equal 180 degrees. Now I'm going to combine like terms. So 5x plus 4 plus 52 makes for 104. 4 plus 104 is 108. And I'm going to subtract the 108 from both sides. So 5x will equal 180 minus 108 equals 72. And divide by 5. And so x equals, well, 72 divided by 5. I'll just crank out some long division really quick to the side here. 5 goes into 7 one time. Minus the 5 is 22. 5 goes into 22 4 times. And then that would be 20. Subtract that off 2. 5 does not go into 2, but will go into 20 4 times, so 0.4. So 14.4 is my answer as a decimal. You could also be using a fraction. 72/5 would have actually been fine. However, that's my answer. Find the value of x, and that's what I was actually after right here. All right, moving on to example 4. So what's happening here? We've actually upped it a little bit. We've expanded this to now equilateral triangles. So this triangle is what's referred to as equilateral, but the same premise applies. If you have congruent sides, they are across from congruent angles. So since this is x plus 12, this is x plus 12, and this is x plus 12. In other words, I could do x plus 12 for every single angle, but here's the deal. Anytime you've got an equilateral triangle, as I do here, you can assume that every angle is 60 degrees. So any interior angle is 60 degrees. And the reason why that is because that's the only way that all three angles could be the same and that they would still add to 180. So I know this is 60 degrees, 60 degrees, 60 degrees. So the easiest way to now approach this problem to find the value of x is just simply take the x plus 12 and set it equal to 60 degrees. Now it's as easy as subtracting 12 from both sides to say that x is equal to 48. Find the value of x. I don't have to go substituting this back in. That's my final answer on example 4. All right, moving on to my final example, example 5. What's going to happen here is we are again looking at an equilateral triangle. Now, it doesn't actually say that on the problem, but I would infer that because every single angle is 60 degrees, that means all three sides must be the same. My task here is to determine the perimeter of triangle ABC. Now, since all three sides must be equal, what I'll do is I'll just take any two of the sides and set them equal to one another to find the value of x at first. So 4x minus 1 must be the same as 3x plus 7 because I am dealing with an equilateral triangle. So I'm going to subtract 3x from both sides to get 1x minus 1 equals 7, and I'm going to add 1 to both sides to finish solving for x. So x equals 8. Now, to wrap this problem up, I'm going to determine the perimeter of that. To determine the perimeter, I'm going to find one side, and I'm just going to triple it, since I know it's equilateral. So I'm going to plug it back into one of these two expressions. Doesn't matter which one. So I'm just going to figure out how long AC is. That's my personal preference right now. So 3x, I'm going to plug 8 in for x, plus 7. 3 times 8 is 24, plus 7, which is 31. Now that I've gotten that value for AC, if this is 31, this is 31, and this is 31. To find the perimeter, I'm just going to have to do 3 times 31, since every side is 31. So the final answer, the perimeter, is 3 times 31 ends up being 93 units for triangle ABC. There's my final answer. All right, let me know what questions or comments you have. Thank you very much.